When confronting a challenge in robotics, two basic programming solutions can be offered up: hardcoding and dynamic coding. But what do these two terms mean? Hardcoding is when parameters and variables inside your code are set to constant values, therefore making the robot perform a single, unchanging function or output. Basically, hardcoding is like giving a blind man instructions to the grocery store. Because he cannot see, he needs to know exactly how far to walk and in what direction. On the other hand, dynamic coding is when the robot's programmed function or output is dependent upon inputs that are read from an external source. The tools used to read from an external source are sensors, which basically act as the eyes and the ears of the robot. In this case, imagine a man with perfect vision trying to get to the grocery store. Because he can see, he doesn't need to know exactly how many steps to take in one direction or the other. He simply needs to know how to interpret road signs. And while this would require more brain power, it is much easier than counting one step. So which is better, hardcoding or dynamic coding? Well, let's think of it in terms of a sailor trying to navigate his ship to a lighthouse. When charting his course, the sailor will begin by setting an initial angle and distance for the ship to travel. And while this initial angle and distance is important, it is not, in and of itself, sufficient for the sailor to successfully make it to the lighthouse. Gusts of wind, stormy seas, and other poor environmental factors will eventually drift the ship from its initial course. So what's a sailor to do? Like any good sailor, he would observe the changes made to his ship's course by the environment and respond by periodically correcting his course. If done properly, the ship would, over time, make it to the lighthouse. This process of periodically correcting one's course involves the use of a feedback loop, where the course of the ship is improved as the sailor continues to observe and adjust the angle of the ship's trajectory. This is synonymous with the process found in dynamically coded robots, where the sensors are periodically modifying the course of the robot, improving its trajectory. However, without the use of a feedback loop and course correction, the technique used for navigating the ship with only an initial angle and distance would be synonymous with hardcoding. So at the end of the day, it's a choice. But at this point, the choice should be quite clear. A smarter robot is a dynamically coded robot. And in the world of robots, the smarter one always wins.